Dear friends, welcome to my video. In this video, I will show you all about the accelerometer sensor of Android operating system or Android phone, rather you can say. So, if one of the applications of Android applications, say for example, counting steps and all those things. So, if you have ever wondered like how all these health apps are able to count your number of steps, or whether how much you have walked, how much you have taken the staircase, or how much you have run, then you will get all those answers in this particular video. So let's begin. Before I get into the coding or the app part, so let me quickly explain you something with respect to like what is this sensor is all about. So in this app or in this program, what we will do is first we will try to get the accelerometer data. Of course, I'll show you in code what are the commands which you have to use, and the accelerometer data by default gives you the acceleration of the phone along all the three axes: x-axis, y-axis, and z-axis. Yeah, so we will be able to retrieve the data or retrieve the acceleration along x, y, and z, and then do our computation further. And one thing to note over here, so if you take the default values or the initial values of this accelerometer, on the y-axis you will see the value of 9.8 or somewhere around that, and the reason for that is because it also takes the gravity, the acceleration due to gravity, which is approximately 9.8 meter per square second. Yeah, so it takes approximately that value, so that is also computed. So many of the all these algorithms which are out there in the market, they consider this and they have advanced algorithm which they design to negate this or to nullify this part. But in this app or in this code, I'll keep the algorithm very simple and very simple. So of course I won't recommend you to follow this algorithm. You can go and do some study, but you should see this video if you really want to learn the programming and how you can do various things with the accelerometer sensor. So in this video, what we'll do is first we'll get the x, y, and z acceleration, and then we'll find the magnitude of this three-dimensional acceleration data. So basically, whatever the acceleration along x, y, and z we have, we'll get the magnitude. So basically, we'll get the distance of that acceleration from this origin point. So once we have that, what we'll do is we'll store the previous or we'll compare that magnitude with the previous value or the previous magnitude value, and then we'll find the delta or the difference between that. If this delta is greater than a particular threshold value, then we can assume that there was some sudden movement of the phone. And from my experience, I've seen like if its threshold is more than 5 or 6, then probably it's a walking thing. If it's more than 10, then probably the phone is in someone's pocket where he's running. Okay, I won't be able to show you about the staircase and all those things, because in that case we have to consider the y acceleration separately. So to keep it simple, I just consider these two use case in my code, where I will be able to tell like how much a person has been able to walk or how many steps he has taken. So let's begin with our Android. So I'll keep the layout very simple. I'll be very quick over here. I'll just do finish in terms of, I'll just put my custom step counter. You can give any name as usual, what I say in most of my other videos. Yeah, and I'll just click finish over here. Is I think that should be fine. So it may take few seconds to create your initial ID. So once it is created, yeah, so the Java code should come up in the front. So before we get into Java, we'll just quickly have a look at our layout, and most probably we'll just leave the layout as it is, because we will just display the count here in this text box. We'll do nothing more, but to retrieve or to get access to this text box, we will need some kind of ID. So I'll just put text view as my ID, and probably I'll increase the font size over here. So to increase the font size, let me see what is the, or I'll just search with size here, and it should give me something. Yeah, text size. So text size I'll probably increase from 36 sp. So yeah, it looks bigger and better. Yeah. So I am keeping the layout pretty simple. I'm not spending any time over here. And now I'll jump to the code. I'll just quickly retrieve the text view I want to keep this video short, so I'll have very simple coding done. That's why I am not investing too much of time on designing the algorithm of step counting. Yes. So in this text view we have our widget. Now as a next step, what we have to do is, once we have this, now we have to create our sensor manager, which will hold the or get the system sensor service. So for that we can use this get system service, and in this we can probably use sensor service. Yes, that's it. So there is some kind of error, and probably let's see. Yeah, I think there is some caching problem. We can just use this cache, and that should solve the problem. Yeah. So it was returning some different. Yeah. So once this you can cache, and then you will get the sensor service written in the sensor manager, and then probably we can now access the sensor from the sensor manager, and the type of sensor we have to access is our accelerometer. So from here we will just go for the sensor manager dot get default sensor dot, so type accelerometer. So if you've seen, there are lots of other sensors as well. I'll try to make videos for other sensors as well, because another interesting one is gyroscope or gyroscope. It depends from which part of the world you are. Some people pronounce it as gyro and some people pronounce it as gyro. Anyway, so but on this video we'll focus on accelerometer. And yeah, so once you are able to access the accelerometer sensor in this particular, then we can put a some kind of listener to this sensor, and so we can create a listener by using sensor event listener. Yes, this one, and we can give any name to this listener. Say for example, I'll give a name a step detector. So because yeah, we are trying to see if it detects the steps or not. So then once you create a new sensor event listener for this particular object, it will automatically create the methods, the respective methods for this. So there are two methods, on accuracy change and on sensor change. I think probably we'll just use this on sensor change method here. So whatever the data of this accelerometer is, we will get whenever there is a change in the value, that value will come in the sensor event over here. So we'll try to extract that information over here. But before I proceed, probably I will do one thing quickly. I will register this listener for this particular sensor what we have created here. So for that we will have to use our register listener command for the sensor manager. So we can use sensor manager dot register. So I think by I should use this small s because that's our object, and then register listener. Yeah, so in this the first input will be our event listener, which is nothing but a step detector over here, sensor event listener. So that will be our first input, and the second input will be, okay, it's not prompting anymore, but I think the second input will be the sensor on which it has to listen, and the third will be the kind of like yeah, delay, whether it should be very fast, priority, normal, and all those things. So I'll just set normal over here, and I think that should be more or less done. Yeah, so this line of code is very important. Please don't miss it out, because then your listener will not get registered to the sensor on which you are trying to listen. So this step detector should get associated to a particular sensor. So this line will tell which sensor it's trying to listen to. So once you have that listener set, then what you can do further is over here. Now we can try to exploit or see what are the values. So as I explained in my document, from this sensor we'll get the acceleration in all the three coordinates x, y, and z. So let's quickly switch back and try to extract it. But before we proceed, we'll just quickly try to check whether this is a not null. value, because if we by mistake do some operations in this, or you can even put a try catch, that should be another approach, but or you can put a if else if check whether this is a not null value or not. If it's a not null, then just we should of course just skip it. And now we should get the values out of it. So probably what we can do is we can have acceleration values, and yeah, these values will be in an array form. So the 0th element will be the x acceleration, and probably we will have to do the same for y and g. Control C, Control V. Of course, I'll change it one by one. So this will be 1, this will be 2, and this will be z, and this will be y. Yeah. So once we have all these values, what we can do is now we can create a kind of magnitude of this. So for magnitude, we'll use the simple formula, the square root of sum of a square of all these three values. So basically the Pythagoras sum, if you are aware of, under a square root of x square plus y square plus z square. So that we can probably take it in double output, and I'll just name it as magnitude, and magnitude should be nothing but a square root. So for a square root, I think I will have to call a math function over here, a square root, and inside this I'll give the square of all of these things. So I can just have quickly Control C. You can again use some kind of operations here to square, but I'll just use the basic multiplication form. Of course, I'll have to change here from x to z, y, yeah. So this will give me the magnitude. Now once I have the magnitude, I have to find a delta from the previous magnitude value. So for that, I should first have a previous magnitude value, and that I can't have it in this method. I will have to create a kind of like, you can say, global variable or like a class variable. So I'll make another variable here called private double previous magnitude previous, and this I'll assign it to 0 to start with. And probably one more variable we'll need is private, and this we can have as integer. This will form a step count, so I'll just name it as step count. So this will hold on the step count, and this also probably I'll initialize it to 0, because yeah, we'll start the step count of course from 0. And once we have all these things done, now quickly we'll find the delta value here. So double and or difference value, whatever the magnitude delta equals to nothing but the current magnitude minus previous magnitude. Yeah. So once we have the delta, now we can do the if else comparison to this magnitude delta. But please note that we also have to keep updating our previous magnitude with the current magnitude, because in the next cycle this current should come as the previous. So we can just update it right over here. Magnitude previous is equal to nothing but magnitude. Yeah. And now we can use our if else command, where we check this magnitude delta if it's greater than the threshold value or not. Yeah, so either you can have another constant, or we can I'll just hardcode over here. So basically if I remember, it was 6 for walking, so I'll just use 6 over here. So if it's 6, so what we have to do is we have to do a step count plus plus. So basically our step count should increase by 1 whenever the delta is greater than that threshold value. So I think more or less, yeah, it's done. So whenever this loop will come, it will keep increasing, and probably, yeah, towards the end what we can do, we can set our text area with this updated value or text view. So text view, set text, and then we should do this step count dot to string. Yeah, that's all. So this will I'm pretty sure will set my updated value in this text area whenever it's working. So please note, it will be hard to understand or visualize this in the emulator. We'll see anyhow in emulator, but it will have a real nice values coming in my real phone. So first let's run it in emulator and see how it comes up. So I'll just use the default Nexus 5X emulator. For the first run it may take some time. Okay, so in the meantime I will also tell you how you can create an APK out of it so that you can test it on your real phone. So for creating a APK you have to do nothing but just go here and inside this build menu you will get an option build bundle or APK. You can just click on build APK. It will take some time and it will create a APK file, and over here it will say APK created successfully, and then it will also give you location of its creation. So I think it's done. So APK file created, and if you have to find the location, you have to just click here and it will take you to the respective location where this APK file is generated. Otherwise it's usually inside the your app folder, wherever your app you have created, and you will be able to find that APK file here. It's with the extension .apk. Yeah, it's called Android package file. So if you notice, our emulator is has come up with this app, and one has come up, and it's not moving or not increasing anymore. And the reason for that is because our emulator is we are not able to simulate or emulate the accelerometer, since there are third-party tools which we can integrate, and probably I will integrate and show it in one of my next videos. But if you really use it in your phone, which I have tested right now, it works really fine. And I will also like to show you in this video that whenever you close this app and restart, this data will get lost, and you will get from the you will have to retrieve the value, or the app will start from 0 again. So what if you want to retain the value for the subsequent app running? So for that also the method is very simple. We'll have to use shared preference option here. So using this shared preference option, you can store some simple or small values. Of course, for big values it's not recommended, because then it will make your app very bulky. Then you can go for some kind of database like SQLite, which is explained in my other videos. Please refer to that. And yeah, but for small 1 or 2 values, you can definitely store it in the app itself, and it will get stored with the app setup file, like in the form of app data. And for that you can use this shared preference. So let me show you how we can quickly create it. So whenever your app is either completely killed, or even if you have paused it, pause means you have switched to some other app, and that time your main app or this particular app will be in pause state. So we'll ensure that in both the cases we are able to save this data for our subsequent run. So it's saying overriding data, so let's use a hint, add super call. Of course we will have to, because we are overriding our onPause method here, not a problem. So yeah, so once you create this protected method onPause, so inside this you should create a shared preference object, and this you can do by using get preference, and the mode you can choose, and by default you should keep mode mostly in the private. And I don't know why this is mode private. Yeah, because in most of the operations we don't want to make this data public to everyone. And once you have it, then what we can do is we can, in onPause and in onStop method, we will be writing the data to the shared preference. So this is a particular kind of object which will store the data in a particular file in your app. So we will have to start this preference in an edit mode. So for that we will create an editor. We'll just where we can go ahead and edit something, and then we'll have this in edit mode over here. So this editor is nothing but the shared preference what we have created over here in an edit mode. Now we can go ahead and start doing whatever we want with the editor, whether we want to write or something, or put integer, put string. But before doing it anything, I think I'll prefer to clear it up with any old data, so better not to mix with something else. And now in the next you can either go for put integer, boolean, float, and you have lots of other options, string also. I think I'll go with integer because we know that our data is integer, and it asks for two things, two attributes. Basically it asks for the string s, which is nothing but a key or the variable to which this particular value will get stored. So as a key you can give any name. I'll give the same name what we have used in this particular code, which is nothing but a step count. And the second will be the integer value what we want to give. So for integer value we anyway have our variable a step count, which is keeping the count of the steps which we have walked till now. And once you have done this, then probably we will have, you can do either editor.commit or apply. I'll prefer to do apply because commit has certain side effects. Yeah, I think more or less this method is done. So whenever there is any pause in your app, this particular method will be called, and this particular few lines will be called, which will ensure that whatever your step count is till that time, it gets stored with the app. So we will have to create similar method for onStop, which means the method or your app is completely killed or terminated or stopped. So for that there is a method called onStop, and same concept will remain for onStop method also. The only thing you have to ensure is superclass is also onStop, and the your main method is also onStop over here. So, and I think rest of the code remains same anyway, because you have to create a particular shared preference and then open it in editor mode, and then write it in the editor. Now what if when you reopen, then there should be some method which should retrieve this data from this shared preference, right? So for that we have to use a method called onResume. So we can use onResume. I think the concept will remain same, and here also I think we will have to add super call, no problem. Yeah. So here also first we'll have to create a shared preference like we did it above. So get preference, and the mode will be of course private. So once done that, now in this it will be very simple. We have to just read this shared preference to get our data which we want. So we'll have our step count, which is nothing but a variable which we are using in this particular code, and then we'll use our shared preference dot get init, because init is what we have stored here, and then the first value is the string s, or basically the key with which we have saved this data here. So we can just do a control C here and control V. So this is a particular our identifier, and the second value is nothing but the default value. So when if there is no such string found in this particular shared preference, then what should be the default value? You can give any value, so I'll prefer 0, so that because anyway in default over here also we have used it 0 over here. Yeah, so I think more or less our code is done. So let's just simulate it again and see how it behaves in our emulator. And yeah, so right now it's 1. I think this is the first call. So what I'll do is I'll just probably yeah, and then again if I go here, so I've killed this. Now I'll try to start that app again. So I am going to start my app again, and I'll just see. So it's my custom step count. I think this is the one. So if you click here, so if you see it's increasing the value. It has become 3, because in each count in emulator, of course it's not able to do anything because we are not moving also at all, first of all. Second thing, even if we are moving with our laptop or computer, there is no accelerometer data. There is no accelerometer in our laptop, so that data is not coming here. So yeah. So but I have installed this for app APK in our in my phone, and it works perfectly fine. So if I click again over here my custom step counter, it became 4 from 3 to 4. So if you see, in each subsequent opening it increases, and the reason for that is in each opening at least one, there will be an increment of 1, because the default value of this magnitude will be, probably because of y expression, it will be something nearby 9.8, and the value which we are initializing it is with 0. So I think that's why in each call at least there is an increment of 1, so it's always greater than, the delta is always greater than equal to 6. Okay, so again, before I close this, I'll just show, don't forget to go to build menu and then use this build APK to build your APK out of this particular app, and the location of the, you can just click here and it will take you to the location, and then you can transfer that APK file to your mobile phone and install it on your phone, and yeah, and it works perfectly fine with your phone, and you and keep changing this threshold value from 6 to 10 and whatever you want, how you want to tune your data. And also, please don't take this as a very advanced algorithm. In this video I have tried to focus on how you can use this accelerometer data, and also I have tried to show how you can retain the data using shared preference option. But yeah, otherwise, if you really want to design a very advanced step counter, then please do some research and go through some proper algorithm, and then design the algorithm in this part of your code. Okay, then I hope this video was helpful to you, and if you like this video, please subscribe to my channel. If you have any comments or questions or suggestions, please put it in my comment section. Thanks for watching my video, and have a nice day. Bye.